Hello everyone, I hope that this video finds you well. Here we are, here's our first e-learning lesson. We're going to talk about stoichiometry. I know that we started talking about this on Friday, but let's focus on it a little bit more. We're going to look at each type of stoichiometric calculation that we're going to have to be able to do for an assessment whenever we decide to have that assessment. Just remember that when we are doing a stoichiometry calculation, we want to make sure we're using a balanced chemical equation, because these coefficients are going to be super important when we're doing those calculations, because these are ratios. We're looking at these numbers as if they're a ratio. So for instance, we have 4 NH3s for every 4 H2Os that we're going to produce, or we have 5 oxygens for every 4 waters that we're going to produce. So we need these ratios and we need them to be correct in order for our calculations to come out to be correct. So like I said, we're going to look at each one of these types of calculations to hopefully be able to solve all of these. And then on the back of this sheet here, you've got some more examples that I would like for you to do, so that way we're practicing this while we're away from school. So let's walk through these examples. The first one is mole to mole. We've talked about this one before. This one shouldn't be too difficult. This is the shortest type that we're going to have to do. We always want to start by writing what's given to us. So we're going to start with 2.5 moles of O2. We're going to set up our T-chart like so. Now, because oxygen is on the top right, we want to put moles of oxygen on the bottom right. Moles of O2, and we're trying to find moles of NO. So now this is where we use the mole ratio, refer to the chemical equation in order to use our coefficients. There are 6 moles of O2 for every 5 moles of oxygen. Now by putting oxygen on the bottom, that cancels that out. So we're going to take 2.5, we're going to multiply that by 6, and then we're going to divide that by 5. So 2.5 times 6 equals, and then divide that by 5, that's 3. Now because our given value is 3 significant figures, we want to report our answer in 3 significant figures, so that's going to be 3.0 moles of NO. So there's our answer. Pretty straightforward. That one only takes one step. This time we just use the mole ratio, which is in this step right here. So not too bad there. Now this is the easiest one that we're going to see. All we're doing is using the mole ratio. Now let's see what happens if we need to go from moles of a substance to grams of a substance. So of course we start by writing what's given to us, 3.0 moles of NH3. I'm going to set up my T-chart. This is going to look similar to what we just did, except for now we're adding an extra step because we're going to grams. Just like this one over here, we had moles of O2 on the top. We had to put moles of O2 on the bottom. Here we have moles of NH3 on the top, so I'm going to need to put moles of NH3 on the bottom. And since we're trying to go from moles of NH3 to moles of to grams of H2O, I need to convert to grams of H2O, or to moles of H2O before I can get to grams of H2O. So let's use the balanced chemical equation. We have 4 moles of H2O and 4 moles of NH3. Remember, we're using these coefficients from our balanced chemical equation. Moles of NH3 cancel. Now, if we wanted to calculate this out, we would know, like this last calculation, we could convert that to moles of H2O, but we want to know how many grams of H2O we have. So now, we'll take this one step further. Moles of H2O are on the top. Grams of H2O need to be on the top here, so that way, because that's what we're trying to find. We're trying to find grams of H2O. Now, based off previous information, if you have 1 mole of a substance, you have the molar mass of that substance. So you're going to need a periodic table to figure out what the molar mass of H2O is. You have 2 hydrogens and 1 oxygen. You should find that the molar mass is 18.02 grams. Moles of H2O cancel. So now we're left with grams of H2O as our unit. So let's plug all this in. We're going to take 3 times 4 times 18.02. Then we're going to divide that by 4, and we get 54.06. We want our answer to be in 2 sig figs, so I'm just going to round that to 54 grams of H2O. So it doesn't look much different from the last one we just did, where we converted to moles, except for we added this extra step where we went from moles to moles, then from moles of H2O to grams of H2O. So we were able to go to grams for this one. Okay, so you're gonna see that a lot of these are just different variations of the same type of calculation, ultimately getting to this one right here, where we're going from grams to grams. But let's look at an example of where we go from grams to moles now. So we're starting with 50 grams of NO. I'm gonna set up my T-chart, where if we have grams of NO on the top, that means we need to have grams of NO diagonal. And since we're gonna be looking for the molar mass, we need to have 1 mole of NO. So I'm gonna figure out the molar mass of NO. Nitrogen is 14.01, oxygen is 16. So that's 30.01 grams of NO. Grams of NO canceled. So we went from grams of NO to moles of NO, but we wanna figure out how many moles of NH3 that's gonna give us. So this is where we use that mole ratio from our balanced chemical equation. Moles of NO go on the bottom. Moles of NH3 are gonna go on the top. Now, what do we use? Where are we gonna find the numbers for this? We're gonna look at the balanced chemical equation. There's 6 moles of NO, 4 moles of NH3. We're gonna cancel those out. So now I take 50 times 1 times 4, so 50 times 4 is 200. And then I'm gonna divide that by 30.01 times 6. 1.11, because we want 3 sig figs, that's 1.11, and that's moles of NH3. All right, so as you're seeing, all of these are variations of the same type of calculation. It all kind of looks the same, but we're going in different orders, or we're adding new steps. All right, now here's the longest one. This is the one that's gonna be the most applicable to things that you're gonna have to do in the future, going from grams of a substance to grams of another substance. This is something that you'll see in a lab. This is something that you'll see on a test. And we wanna definitely be able to do this one along with all of these. So let's go from grams to grams. This says 100 with a dot. That's just indicating that we're going to have 3 sig figs in our answer. So we're starting with 100 grams of H2O. I'm gonna make this one a little bit longer because I know it's gonna take more steps. Grams of H2O are on the top. That means diagonally, grams of H2O go on the bottom, and that's for 1 mole of H2O, because we need a molar mass. Molar mass of water is 18.02. We used that previously right here. But if you don't memorize it, you get that from the periodic table. 2 hydrogens, 1 oxygen. Grams of H2O, cancel. Now, we have moles of H2O on the top, so I'm gonna go diagonal there, and we're trying to go to grams of O2. So I need to convert to moles of O2 first. Let's use the balanced equation. 4 moles of H2O, we have 5 moles of O2. Moles of H2O cancel. So this looks similar to this last one we did, except for now, instead of stopping at moles, we're gonna stop at grams. So now moles of O2 are going to go diagonal here, so we can cancel those, and then grams of O2 go on the top. So because we're going to the molar mass, we need 1 mole of O2, and that's gonna have a mass of 32 grams. Because it's O2, that means there are 2 oxygens. So you need to take the mass of 1 oxygen, which is 16, and multiply that by 2. So now moles of O2 cancel. We're just gonna take all these numbers, 100 times 5 times 32. And then we're gonna divide that by the bottom, which is 18.02 times 4. So here we go, 100 times 5 times 32. Then I'm gonna divide that by 18.02 times 4. What we get is 221.9755827, but we want our answer to be in 3 significant figures. So that's just gonna round to 222, beautiful, grams of H2O, or O2, sorry. We're going to O2. So that one, 1, 2, 3 steps to solve that one. The rest of them, these two are 2 steps. This one is just 1 step. But all of these, we're using the balanced chemical equation. Some steps we need to use the periodic table when we're converting masses. Sometimes we need to use the mole ratio from this balanced chemical equation. So hopefully walking you through these 4 types will help you go through the examples that are on the back of this very page that I was just showing you. I want you to work through these 5, A and B for some of these. Do that on a separate piece of paper or print this out on your own. Take a picture of it, put it in the Dropbox. That way I can see that what you're doing and I can give you some feedback, so that way I can see if we're ready to move on to the next topic. Stoichiometry is just something that we need to use for the bigger picture of this unit. So make sure you're practicing this while you're out of school, and send me emails if you have any questions. All right, guys, take it easy.